has a smaller value. Therefore, okay, buckling will occur from the XZ plane or about the y-axis. Okay, so from here, our critical load will be equal to pi squared Young's modulus. So I need to, can you all write this down? So given, okay, E is equal to, I forget to write this. So given that E, capital E, is equal to, for this material, capital E, 73.1 times by 10 to the power 9 Pascal. And the stress U is equal to 414 times 10 to the power 6. Now, this can be from material handbook or can be from anywhere, okay? But if in the exam time or test time, I'll give you all this value. I don't know how to look for in the material handbook, okay? So over here, we can immediately write down that this is pi squared E, then 3.1 times 10 to the power of times 10 to the power of 9. Young's modulus, we are going to use the 1.0417 because it's the smaller value, means buckling will occur with the smaller I. And why we choose a smaller I? Because the equivalent length is the same. Okay. So this will be equal to shift pi squared times by 3.1 power 9 times by 1.0417 power minus 6 divided by 3 is equal to 83.506. 83.506 times 10 to the power 3 Newton. Okay. So this is going to be our critical load. Okay. So with this, right, now this PCR is from where? Under centric loading, right? This is under centric loading. So when that's the case, we have to check that stress U is greater than PCR divided by area. Right? Why we use PCR divided by area, which is our critical stress? This is because of what? Centric buckling. Okay. So from here.
Eugene?
Yes. Hello?
Oh. Yeah, I was thinking if it turned out to be eccentric buckling that will have the lower second moment of area, would we have used this formula?
Repeat your question.
If it was eccentric buckling that had the lower...
You don't use this formula anymore.
Okay.
Because eccentric buckling, the formula all changed already. Right? It changed to be this formula now. Right? It changed to be this formula over here. No more force divided by area. Yes?
Yeah.
Okay. So from here, because it's under centric buckling, so next we need to do is just do 83.506 times 10 to the power 3 divided by our cross-sectional area, which is equal to 0.01 or 0.1 divided by 0.05. So this is equal to 83.506 power 3 divided by 0.1 by 0.05 is equal to 16.701 times 10 to the power 6 Pascal, which is less than our stress U. So the next one, so now we know that this load is the maximum that we can apply. If we were to use the other formula, okay, if we were to now, okay, we are going to look at the stress, okay, based on eccentric loading now. So I'm going to copy this diagram. Okay. So now we have to test. Okay, after knowing that, we have to test if the P critical, which is equal to what? If it's equal to 83.506. No, is it no? Yeah, 83.506. Or 503. I think 83.503 Newton. Right? So sorry, this is not PCL, this is our P. Sorry. Okay. So if this is now our P, right? Test if now our applied load P, right, will induce or test, not test, determine, not test. Okay, so determine when P is now equal to 83.5 will induce, okay, stress max value of stress max greater than stress U. So now we have to test this out. Okay, now we have to test this out. What is the value now? Okay, so with this, okay, now this becomes our P. So P now becomes 83.5. Okay, now our PCR now, because of the axis that we are looking at, so become pi squared E. Now we find IYY over LE squared. Okay, so now that is our critical load. So what happened is, okay, over here we found that this is our PCR under centric buckling. So now we replace the PCR by what? P over here, which is 83.5. And now we have to find our different PCR because now buckling occur about the what? Not IYY, I do apologize. Occur about the IZZ axis now. Okay. So IZZ axis, we know that this is pi squared. E is still the same. E is our what? What is our value for E? E is 73.1. Now our IZZ, right? So now our IZZ is this value now. It changed already. You can see that, right? So it's 4.1667. And our LE change. LE, sorry, not the same. Change is still the same, 3 squared. Okay. So this is equal to pi squared times by 73.1 power 9 times by 4.1667 power minus 6 divided by 9. So it's equal to 334.016 times 10 to the power 3 Newton. Okay, let me do it again. Pi squared times by 73.1 1 power 9 times by 4.1667 power minus 6 divided by 3 divided by 3. So it's equal to 334.016. Okay, so now we got this now. And then all we need to do, let me get that whole formula over. Then it's easy. Okay. Right. So we have our P, we have our PCR, we know our E, R squared, we don't know, right? R squared, we don't know for now. So we know that IYY is equal to A RY squared, right? So RY, no, is it YY? No, ZZ. So we know that this is IZZ is equal to A RZ squared. So RZ is equal to square root of IZZ divided by A. So IZZ we know is equal to 4.1667 times by 10 to the power minus 6. Divide by area. We did calculate area before. So area is 0.01 divided by 0.005. So 0.1 divided by 0.05. So our radius of gyration 4.1667 divided by 0.1 divided by 0.05 squared by the whole thing is equal to 28.868 times by 10 to the power 3 meters. Okay, so we have our R squared. Now our C value. Okay, so C value is this distance is our C value, right? So we know the distance from here to here is 0.1. C is equal to 0.1 divided by 2 is equal to 0.05 meters. That's it. Okay, so from here, we found that our stress max will be equal to P, which is 83.5 times 10 to the power 3, divided by our cross-sectional area, which is 0.1 times 0.05 is equal to 5 times 10 to the power minus 3. And then we have bracket 1 plus by E. E is equal to 0.15 and C is equal to 0.05 over R squared, which is equal to 28.868 times 10 to the power minus 3. And then we have secant, and then we have pi over 2 square root. P is 83.5 times 10 to the power 3. And then
Eugene, you forgot to square the radius of gyration.
Yep, thank you. Squared. You just give me a fright there, but it's a good fright. It's 83.5 times 10 to the power 3. And the PCR now is 334.016 times 10 to the power 3. And then the whole thing, I close my bracket. Okay, so this will be equal to 83.5 power 3 divided by 5 power minus 3 is equal to 16.7 times 10 to the power 6. I'll do it again. 0.5 power 3 divided by 5 power minus 3. So it's equal to 16.7. 1 plus by 0.15 times by 0.05 divided by 28.868 power minus 3 squared. So it's equal to 9. Let me do it again. 0.15 times by 0.05, 28.868 power minus 3 squared. It's equal to 9. 9 bracket 3.5 power 3 divided by 334.016 power 3. Square root the whole thing times by 5 divided by 2. Cosine by the whole thing. 1 divided by cosine is equal to 414. Okay, I'll do it again. I don't have confidence now. So square root of 83.5 power 3 divided by 334.016 power 3, close bracket, times by shift pi divided by 2, cosine by this, 1.414. So 1.414 times 9 plus by 1 times by 16.7 power 6 is equal to 229.224 times 10 to the power 6 Pascal, and this is less than our stress yield, which is equal to 414 times 10 to the power 6 Pascal. Okay, so this question is a bit tricky. The tricky thing is about if in the XY plane, we already calculate the pre-critical in the XY plane. And then when we switch over, this become P, and our P critical change because of our second moment of area is taken in the different direction or different axis now. Okay, if that's the case, thank you for the time. I'll post the homework tomorrow. I'll see you guys on Thursday.
Thank you.